Hello students, this is Professor Venkatachalapathi, Institute of Aeronautical Engineering. I am going to discuss about forging defects. In the manufacturing process, we have studied about metal casting, welding process and metal forming or mechanical working of metals. In every process, there will be some defects. So like casting process, casting defects, welding process, welding defects, forging process, forging defects. In this session, I am going to discuss about what are the various forging defects and what are the causes and its remedies and how do you identify the forging defects while performing hot and cold forging process. Let us see forging defects, its types and causes and remedies. We will learn about forging defects, its types and causes and its remedies. So defects are common in very manufacturing sector, especially in the casting process, which include casting defects, welding process, which include welding defects, and at the same time forging, which consisting of some defects which are due to both process and human limitations. Isn't it? Both the process and human limitations, we will call it as these forging defects. So now let us understand clearly how we can able to explain the forging defects and some of the remedy or effective of causes that defect cause and how we will able to give the remedies we will discuss. Okay. As you know that forging gives the better mechanical properties among all the manufacturing process. Look at forging gives better mechanical properties among all the manufacturing process. Why? Because in a casting process only it is in a porous in nature. Casting process it is in a porous in nature, and the secondary process of welding some lines. Okay. And in forging process, even in the sharp corners also, even in the sharp corners also, it may be filled easily. So that the forging gives the better mechanical properties when compared to metal casting and welding process, etc. So, and it also includes some of the common defects which we would like to discuss clearly from the coming topics. Okay, let us see. First, the defect is unfilled section. So, as you know that look at the any component, it is a die. How you can see the gap. So, this is called unfilled gap. Unfilled gap. Especially in this unfilled gap, why it has been performed. So what is the causes and how do you rectify it? Improper design also, it lead to be some unfilled defect may be occur, and also sometimes filled surface also overfilling also can be done. The overfilling, some flashes and extra material come out of the die, that is also will comes under the forging defect. Okay, and let us see the first point or first defect in the forging. We can call it as a unfilled section. So in any defect, either it may be casting defect and welding defect or forging defect, this can be explained in a cause and effect diagram. So that is cause and effect diagram, or you can also call the Ishikawa diagram. Ishikawa diagram. So that means, so what are the causes which will influencing the effect? So for example, unfilled section. This is the defect which will be occur due to causes. What are the causes of this unfilled? So for example, as the name implies in this type of defect, some of the forging section remained unfilled. Do you know that this is what you can, here there is some gap. The total amount of raw material completely not filled. So that is why we will call it as unfilled material. So this is due to poor design. So here the main cause is poor design. Yes or no? So poor design. So which will implies that the defect may obtain unfilled defect, and at the same time, poor forging techniques. There is another poor forging technique. So in number of process are there in forging process. The way you have to use the forging technique, either it may be open die forging or closed die forging, and what type of method it is, either it may be smith forging or drop forging or press forging or machine forging, and the method to be used effectively, the technique to be maintained effectively. Obviously, these are, for example, the two major causes which will get this forging defect is unfilled. Okay, unfilled section is the defect, and this can be remedy of that. The design can be improved better. The poor design which will imply the unfilled section, you should able to identify the design should be effective. Quality design should be made while performing this forging process. If your design is not proper, obviously the complete filling cannot be occurred. So automatically another thing is the type of forging process or forging technique also very important. Suppose if there is a smith forging process, there we will heat the metal through some of the small heating blowers, furnace, etc., and where you can apply pressure through manually. So by repeated blows, so that lead to be somewhat uneven surface finish may be obtained. So that is called the smith forging. Similarly, if you say smith forging by using the pressing machine, means it is not applicable. That's why the forging, what type of process to be taken into the consideration for different type of application. So that is why, otherwise if it is a press forging process, the principle to be done, we are using the manually, it is not up to the mark for that technique. So that is why that improper poor forging technique leads to be unfilled section. Okay, it is not properly filled into the closed die when it is a closed die forging. In open die, exactly the workpiece can be kept effectively in order to change it the cross section shape and size. Okay, and that is why this is due to less raw material or poor heating also. Another important thing is raw material is less raw material. Okay, and another thing is and temperature. Okay, poor heating. So whenever, in order to eliminate this unfilled section defect, what you are supposed to do, what are the remedies? You should improve the design. Design should be improved. So improved design, then automatically the unfilled will become filled. At the same time, the proper forging technique to be used. Proper forging technique to be used. Obviously, we will get the correct filling section can be obtained in the forging process. And also the raw material. So very less raw material means that obviously, for example, a 50 grams of amount is used for the filling in the die. Only the 50 amount you can use the raw material also 50 grams. Suppose if you use the 45 or 48 grams, means the 2 grams will be unfilling. There is a gap should be there. That is why the gap should be formed in this shape of the forging process. Okay, so that is why it is a unfilled surface. Okay, unfilled section defect can be obtained. Improper poor design, improper forging technique, and improper raw material, as less amount of raw material, and poor heating. So whenever, depending upon the material itself, we can able to maintain the proper cooling temperature or heating temperature, then only you can able to have the correct section of the component. Either it may be automobile or aeronautical, what type of application, you can able to maintain the 4 factors. This is why cause and effect diagram, which is also called the Ishikawa diagram. This is also called the Ishikawa diagram or fishbone diagram. So why it is called the fishbone diagram? Just like a fish, these are the arrows. Chapa mullu antaru kadamma. Like that fish bone diagram. If you take the fish bone, so like that some arrows will be there, and which will affect based on that here. That arrows only, what are the factors, what are the causes for getting this defect. To eliminate this defect, you can improve the remedy for these causes. Poor design, proper design to be maintained. Poor forging technique, corrective technique should be allotted. And less raw material, exact amount of raw material. You can take a weight of that sample, weight of the sample of the workpiece. The exact amount, either 50 grams or 100 grams or 150 grams, the same amount of raw material is kept into the die. The same amount can be get manufactured in the output of that product. Okay, and also poor heating also. When you can, depending upon the heating, will classify into two things. One is the hot working process. The second one is the cold working process. Once again, hot forging process means heating the metal above its recrystallized temperature. For example, either here ferrous metal is steels or alloy steels or different type of materials to be used. Exactly what is the melting point of that material, you should be able to consider. You can heat, but if the heating can be reduced, there is a shortage of the raw material. Because if it is cool means it will be elongated. Space occupation also will be occurred. So this is what about the unfilled section. And similarly, another defect we can call it as cold shut. So cold shut is the one of the another important type of forging defect. So how it will occur and what are the causes and how we will do the remedy of this cold shut forging defect. Let us see the in this diagram. So in this diagram you can clearly see that there will be some defects, improper defects, some at the sharp corners only some excess and projection and some defects will be occur. Okay, so that is why it is called cold shut for the folding and cracking at the flash. So whenever there is a break occur, some extra amount of raw material come out. Okay, so let us see the cold shut means cold shut, which include the small cracks at the corners. So whenever any type of component at the ends only, small cracks at the corners, and these defects occur due to improper design of forging die. So once again, I am focusing with the help of the cause and effect diagram. So for example, the defect is cold shut. Yes or no? Defect is cold shut. In this cold shut, what will happen? What are the causes to obtain this cold shut? Cold shut also, the improper design is one causes to obtain this cold shut. And one more thing, it is also due to sharp corners. So wherever by joining at the two lines together, so with the sharp corners, due to sharp corners are there, it is very dangerous to further defect also. Sharp corners. And excessive chilling in a forged product, that is cooling, more cooling also can be occur. This cold shut defect may be obtained. In general, the term cold shut can be defined as wherever the small cracks occur at the corners of a given workpiece or specimen. Okay, so that is why we can know the identification of that defect is called cold shut. Okay, the name itself, cold shut, even the more cooling also can done some flashes and some corners in the extra cracks may be obtained in that corners only. So okay, this is what about. And one more thing is sharp corners means, look at this is a sharp corner. How do you eliminate? Try to use the fillet. Okay, so you can do fillet. This can be eliminated with the some finishing process. Okay, and another important thing is fillet radius of the die should be increased to remove these type of defects. That's why fillet, if it is there, here the radius should be 0, and if you increase the radius, fillet radius, instead of perpendicular, it will come to a some concave shape, and this smooth finishing may be obtained. Especially you can see the, even here, this, see in this pen also there is a fillet can be obtained. So if it is not fillet, there some sharp corner may be occur. When it will touches also some cracks and danger to be done for the human beings. Okay, so this is what about the cold shut. And this remedies, there is a defect called the cold shut because of improper design and sharp corners and more chilling effect, more cooling. So to avoid such a defect, obviously the design should be a proper. You should maintain proper design, and at the same time sharp corners can be eliminated by implementing the increasing the radius of the fillet radius. And cooling also, once the heating can be done, and after applying the pressure, immediately it will be cool. If you provide the more cooling, which leads to be some cold shut, some cracks, and what you call some improper due to the what you call the cracks, small cracks, small flash will come out. These all comes under the defects of the cold shut only. Okay, so this is what about in unfilled section and cold shut. Look at the important information regarding cold shut. Means cold shut which include the small cracks at the corners. So from the diagram you can see some cracks here, and even these cracks also may get at the corner shapes only. Some cracks may be occur. So in order to eliminate that corners, that fillet radius, you can able to increase the fillet radius. If it is a perpendicular to each other, the radius should be 0. If radius can be increased, it will become like some what you call some arc may be produced, so that there is no problem in the surface of the end product. Okay, so the fillet radius is the one of the main criteria for avoiding the sharp corners. Okay, so this is what about the unfilled section defect and cold shut defect. Next one is scale pits. So another important defect called scale pits. And next thing is die shift. Okay, look at in this diagram. So these are the some three-dimensional forging defect. When you take the photographs when it will enlarge, obviously the defect can be able to observe and to identify why this defect has been occurred and what are the remedies to be taken, and you can able to remove the defect. And next process, you should eliminate the forging defects also. Look at, these are the scale pits. So actually scale pits are due to improper cleaning of the forging surface. This is very interesting. Improper cleaning of forging surface. Whenever, so there will be a workpiece, and we can keep upper die, closing die, and here you can keep the workpiece. This is called workpiece. Okay, so in this workpiece, obviously the once you have to remove the workpiece, you should clean it properly. Otherwise, what will happen? Some scale pits, unnecessary, some small black in color may be obtained. That is called the scale pits. and even the rust formation, even if you metal like iron and steel etc can keep in separately open to the atmosphere, so because of the air particles and some foreign particles and all, after some time it will become a rusted. So if didn't see, then that some of the material also can be eroded with the corrosion process. Okay, so this is what about scale pits. Scale pits are due to improper cleaning of forged surface. This defect generally associated with the forging in open environment. That is what I have been explaining. Scale pits are some corrosion and some of the dust, some iron. If you keep the iron separately, also rusting can be occur. So you should not, you will want to eliminate this type of defect. Obviously, the first and foremost important thing, whenever by performing the forging operation, you should clean the die and workpiece properly. Then only what are the shape and the size can be obtained easily. And whenever in the open environment, due to foreign particles, some extra material will come out to fell in that workpiece, which leads to also a scale pit of defect. And it is a regular depositions on the surface of forging. So these can be occur in regular in conditions, and it can be removed by proper cleaning of the forged surface. Whenever, so here you can see the workpiece. This is the die, upper die, lower die, upper die, lower die. In between you can keep the workpiece. Whenever this workpiece putting on that mold or in this die, you should clean properly the die, then workpiece, then you can apply the pressure. And if it is a heated condition, you can take it into some of device where it is difficult to handle the hot metal. So that's why you can handle with the proper mechanized instruments. Okay, so this is what about the scale pits. And another important thing is die shift. So this is a very interesting die shift which is caused by misalignment of upper die and lower die. So for example, so there are two dies are there. Okay, misalignment. Even if you take the pen also, why, if the diameter of the pen should be less than the diameter of cap, so that is why the pen can be entered easily. Suppose the diameter of the pen can be increased, can able to fit inside, it cannot fit. So that is why die shift, most probably it will occur misalignment of upper die and lower die. That leads to when both these dies are not properly aligned, the forged product doesn't get to proper dimensions. Here, because of the die shift only, dimensional accuracy can be very less. When wanted to increase the good dimensional accuracy, you should able to align properly of the bottom die, top die. So these are correctly matched and we can able to keep effectively. Okay, and this defect can be removed by proper alignment, and it can done by half notch and upper die and half lower die, so that the time of alignment both these notches will be matched. So notches, since it is a rectangular notch and triangular notch etc. So this is also the die shift can be explained with the help of Ishikawa diagram or cause and effect diagram. So for example, so the effect is die shift. What are the causes which will occur this forging defect die shift? So why? Because the die shift is caused misalignment of upper die. So misalignment of die. Misalignment of die. And the second important point is these dies are not properly aligned to forged product. It doesn't get proper dimensions. So whenever, so if it is not aligned properly, the dimensions also very poor dimensions. Poor dimensions. Okay, and this defect can be removed by proper alignment. Whenever the misalignment is there, obviously you should be able to align properly. So this is why it can fit effectively. So whatever the exact amount of tolerance and length can be maintained. That's why this easily can be fitted with the cap also. Okay, and whenever the die also, bottom die, top die, and these two dies are very important, and you can maintain properly with the good dimensions, and at the time of alignment any change, any range can be changes its dimension, definitely it leads to be some of the forging defect techniques. This is also called the defect technique. Die shift, okay, even by applying the pressing machines, obviously by lifting the pneumatic or hydraulic machine, so there is a small type of errors also will be there, that as an engineer you should be able to rectify the error, and then only you can able to operate the forging process, and then what are the defects can be obtained using that type of product. Okay, so this is what about the scale pits, and another thing is die shift. Okay, so obviously the die shift, even by applying the open die forging, we apply manually. For the one shot, it may be changes it the position. So similarly, if it is a hot forging process, what will happen? This can be removed by proper alignment, and also that notch, if it is a what you called rectangular notch and V notch. So these are all very important to eliminate the this die shift defect. The die shift defect can be removed by proper alignment. Majority of the this metal working or mechanical working of metals, there this dies and presses are most widely used in order to maintain the proper quality and dimensional accuracy. You need to assess the die shift defects, and what are the remedies of that defect, what are the advantages. Okay, so cause and effect. Because of this cause, the effect may be changes. Okay, so there is a breakage will be occur in this overloading and heating and applying the pressure. Okay, so this is what about the scale pits and die shift. Next, another interesting one is flakes. So in general, flakes means air gap. These are the flakes, graphite flakes. Okay, so graphite flake and some different type of thinny shaped line. We will call it as the flakes. So in this diagram, you can see the how the flakes will be explained with the help of the simple diagram. Okay, so whenever by applying the pressure, or whenever by applying the heat, obviously that technical machines, and which can be more useful for the performing better application. So, and another thing is improper grain growth. So here let us see the grain growth also very important. Improper grain growth which occurs due to improper flow of raw material in casting, which changes the paraffin grain structure of product, paraffin grain structure of the product. It can be removed by the proper design or incomplete forging penetration. So another important defect is improper grain growth in incomplete forging penetration. So especially some of the three-dimensional defects diagrams has been introduced here. Look at, these are the flakes, how the flakes can be obtained, and these are the some crack. So why the crack will occur in this forging defect? Because if it is a cold working process, obviously less for large forces are required to change in a small positions also. But in the case of die shift and scale pits, cold sets, and unfilled section. So these are the some basic important defects, even in the examination point of view, either internal or external. Any one defect may ask in the examination, either casting defect or melting defect or forging defect. So in the forging defects, in meantime, you can see the important thing is uh, flakes. Okay, so these are the internal cracks occur. These are the internal cracks that occur to improper cooling of the forged product. So when the forged product cooled quickly, so after doing this changes of admission, you can cool quickly, and these cracks generally occur, which can reduce the strength of the product, which can be reduced to the strength of the product. This defect can be removed by the proper cooling process. This can be moved by the proper, what you call improper grain growth. Okay, so let us see the improper grain growth. As I already discussed about grain growth. Okay, grain growth. So because of this principle, okay, what is the importance of grain growth, how we can able to maintain the proper grain growth. So okay, in this defect, majorly it occurs due to improper flow of material, in casting process, whereas the changes in precedence, predefined grain section of the product, and it can be removed by proper die design. Okay, proper die design. So this is the sixth important forging defect. Next thing is incomplete forging penetration. So whenever this defect arises due to incomplete of forging, so whenever for all the manufacturing process, that cycle time will be varies. Okay, depending upon the application, depending upon the usage. So this can be improved. Okay, incomplete forging penetration is the one of the most important defect. Okay, so where it is due to light or rapid hammer blow, this defect can be removed by proper control on forging press. So all this in the right side three-dimensional diagram. So even the examination also you can write it in simple way, so that these are the flakes, crack, cold shut, scale pits, and die shift. Okay, and finally unfilled section or filled section. So whenever the unfilled is there, material shortage, and when it is filled means you need to understand clearly how the forging defects has been introduced in the second BTech second semester mechanical engineering student. Okay, so that is why this defect arises due to incomplete forming, and it is due to light or rapid hammer blows. Keep on putting blows. So this defect can be borrowed from controlling of the forging press. Yes sir, na? So in general, look at forging defect. First and foremost thing is unfilled section, second cold shut, and third one which belongs to scale pits. So due to oxidization, some what you call extra foreign particle fed into the workpiece. So that you need to understand clearly about the this defects of the forging process. So in general, scale pits, another important type is what you call the scale pits. Scale pits are due to improper cleaning of the forged surface. Okay, it is improper cleaning of the forged surface. This defect generally associated with the forging in open environment. This is irregular deputation on the surface grinding or surface forging. It can be removed by proper cleaning of the forged surface. Removing the proper cleaning of the forged surface. So these are another important type of forging defects. Let us see die shift. The die shift is caused due to misalignment of upper lower die. Okay, so whenever you can able to maintain the uniform K, and this what you called this incomplete forging penetration means this arises due to incomplete forging. So this will arises due to incomplete forging. It is due to light or rapid hammer blow. Obviously, the defect which can be removed by proper control of the forging press. There is a Smith forging is there, machine forging is there, and different microstructural or microcontroller machines also available. Okay, so this is what about the another important type of uh, forging defects. Now another two last but not least, so cracking. What is meant by surface cracking? Okay, and surface cracking, and another thing is residual stresses in forging process. Residual stresses in forging process. So look at the important point is surface cracking. Why it is called surface cracking? So surface cracking majorly occurs due to exercise working on surfaces at low temperature. So in this defect, so many cracks arise on the workpiece. So many cracks arise on the workpiece. This defect can be removed by proper control of working temperature. Okay, proper control of working temperature. And all are the main types of outgoing defects. All are the what you called this defect can be removed by proper control on working temperature. So whereas in this residual stresses in the forging means this defect occurs due to improper cooling of forged part. Improper cooling of the forged part, and too much rapid cooling is the main reason for the system. By type of defects, okay, so the main causes of this type of defects, this can be removed by slow cooling and forged product. Okay, slow cooling or forged part. So these are the all main types of forging defection. Okay, and some right side cracks, surface cracks, how they can able to fix it in the bottom or the workpiece, and there will be a roller and you can rotate it. And what are the internal cracking which cannot be seen? You can see from the diagram itself how much cracks can be obtained while performing this hot extrusion process. Okay, residual stresses in and forging. What are the various residual stresses are involved in the forging process? And in this case, residual stresses in forging, this defect occurs due to improper cooling of an forged part. So this occurs due to improper cooling of a forged part. Too much rapid cooling is main causes. Too much rapid cooling is also a main reason for this type of defect. This can be removed by the slow cooling of forged part. This can be removed by the slow cooling of forged part. So these are the some basic important type of forging defects, and how this forging defects can be causes, and what are the remedies to be considered for performing these type of defects. Also surface cracking, residual stresses, in all these main types of forging defects. Okay, so these are the main important types of forging defects. Okay, and this is what about the forging defects. Already have studied about the term forging can be defined as when it is a hot forging means what you called this forging defects. It is similarly like casting and material science, and that's what the welding defects, which will compare to forging. It is an extraordinary properties, and among the all the manufacturing process, but it is included some of the common defects which are described below. Okay, so in this diagram already has seen there is a topmost some gap will be there, that is called unfilled gap. So here the horizontal lines are structural will be changes into the unfilled surface or filled surface. In the filled surface, extra material come out. So that is why the heating cost may be increased, and also The forging gives the better mechanical properties among all the manufacturing process, but it is also include some of the common defects which are described. That is what unfilled section, cold set, scale pitch, die shift. Okay, and flakes, graphite flakes, like graphite flakes, you can able to use some graphite flakes. Okay, and improper grain growth. How you can able to apply improper grain growth and incomplete forging penetration. So, okay, so this defect arises due to the incomplete forging, and it is due to what you called due to light rapid hammer blow. Any changes of the uh, this process. So obviously you need to understand clearly why this defect will be happen, what are the importance, and how we can able to use in this present 2022. Okay, and that's why these defects are arising due to incomplete forging, and this is due to light or rapid hammer blow. Okay, in this design, it can be removed by proper control of forging press. This is also proper control of forging press. So thank you guys, and today my class is over. In the next class we'll make a plan to design how the forging defects, how it will be able to appreciate it in this applications. So that is why flakes, improper grain growth, proper incomplete forging penetration, surface cracks in some powder metallurgy. Always they can use the what you call that pin and some sharp kind of equipment. So that leads to be a lot of rapid cooling also is main causes in this type of defects. This can be removed by slow cooling or forged part. So that is what about slow cooling and what you called pressure. If it is a cooling, automatically you can apply a lot of pressure to be obtained. And if it is a hot condition, both heating process will be there, cooling process can be there. So that is why all these are main types of burn-in defects. Whenever it can occur the surface cracks, even you can see in the medical universities like Mallarati University and Vignan Geetham. So all these universities, they have some problem in the laboratories. Okay, so how do you convert that problem into a real one where you can able to perform better? Okay, so this is the another important type of forging defects. Okay, good luck.
Like, share and subscribe. Hit the bell icon for more updates.